Okay, this looks to be a super simple problem here at first. Sine theta cosine theta equals -1. And like we've always liked to do, we always like to have it either in sines or cosines. And that's a little bit tough to do here. So because the formula that we've used up to this point to do this has been the sine squared plus cosine squared equals 1. And I don't have any squareds. So is there another way to get around this? Well, there is. If I remember my double angle formula, I can take this and double it. So it'd be 2 sine theta cosine theta. If I double this side, that's -1. Okay, now this is the double angle formula for sine. So this is actually sine 2 theta equals -1. And once you get to here, this is really pretty simple. So the next step is you're going to arc sine both sides. So you're going to arc sine -1. And I did change the period, so when I do this, 2 theta equals 3 pi over 2. It's the arc sine of -1. I want to add my plus 2 pi k on here. So that's going to make it a little bit more obvious that there's more than one answer to this. So I divide everything by 2, and I get theta equals 3 pi over 4 plus pi k, which means theta is obviously going to be 3 pi over 4, but I'm also going to add 4 pi over 4 to that because that's equal to 1 pi. And that's going to be 7 pi over 4. And that gives me a second answer that's in this range right here. Okay, if I try to add another one, I get 11 pi over 4, and that's more than 2. So 2 pi. So that's it. I don't have any other solutions. Just those two. So it's very helpful to remember your double angle formulas in this case.